Alright, for this section we'll be looking at applying some properties of definite intervals. So those definite intervals give us the area underneath the curve, and we're going to look at some different ways we can break those down. So the first thing that we're going to look at is for if f is defined at x equals a, then the integral from a to a of f of x dx is going to equal 0. This is because you're going from a to a. So if you think about that on your graph, if a is right here, if I'm looking at where I'm going just from a to that same point, I have no width for my area there, so I'm just going to get 0 for that. Our next property that we're going to look at is that if f is integrable on from a to b, if we can take this integral, then the integral from a to b of f of x dx is going to equal negative the integral from b to a of f of x dx. So if we have the area underneath the curve from 3 to 7, if we switch our limits right here, so we're looking at those limits right there switching there, then we're going to have to put this negative out front. So we'll have the opposite of what we get whenever we do it with the limits switched back. For 3, f is integrable on the 3 closed intervals determined, a, b, and c, where a is less than b, less than c. So what we're thinking about here as far as the graph goes is that we've got on our x-axis our a is over here, our b is somewhere in between, and our c is to the right, and we've got some sort of graph here. So whenever we see this integral from a to b, that would be this area right here, and then our integral from b to c would be this area right here. So as long as we are dealing with something that we can take the integral of, we are looking at this equaling the integral just from a to c of f of x dx. I haven't really specified why we have to have this dx here. This means with respect to x, so you're taking the derivative with respect to x here. For right now, you just pretty much need to make sure you write it every time. We'll talk more about why that dx is there later. Okay. For number 4, if we are taking the integral of two functions that are added together, much like with derivatives, we can take those integrals separately. So the integral from a to b of f of x dx plus the integral from a to b of g of x dx. Of course, this would also apply if you had subtraction as well. So if that was subtraction instead, you could still break these into two separate intervals. For number 5, we have a constant. So right here, if k is a constant, and we can take the integral, much like with derivatives, this k can be pulled out as long as that is a constant that does not have a variable with it. So this would be k times the integral from a to b of f of x dx. And then, all right, our last one here, fix a mistake there. Our last one here is going to be the area under a constant. So if you think about what that looks like, that's just a constant right here where k is that y coordinate. So if you're going from a to b for this integral, it's just going to be a rectangle. And the height of that rectangle is going to be k, and the width is going to be b minus a. You're going to subtract those two. So your constant, you're just going to have k times b minus a there, because you're just dealing with a rectangle. So let's look at how to apply this. So some of the questions that you're going to get, they're going to give you pieces of information that you know, and they're going to ask you to find some other integrals given those pieces of information. So they give us the integral from -2 to 8, from 3 to 8, and from 0 to -2. So the first one asks us for the integral from -2 to 0. And we can see they gave us the integral from 0 to -2. So all that has happened here is that these two limits of integration have been switched. And so if we switch limits of integration, we're just going to get the opposite sign of what we got for that integral in the first place. So since this is a -3 right here, we will get a +3 as our answer for that one. For the integral from 0 to 3, if you kind of think of what sort of a number line of what we've got here, we've got from -2 up to 0, and then they give us some information about 3, and then 8. So they're asking us to find the integral from 0 to 3 here. We just found -2 to 0 right here, and then for this part they give us 3 to 8. So if I add all three of those together, it should give me the integral from -2 to 8 based on those properties there. So if I do the integral from -2 to 0, you want to put your lowest number first there, -2 to 0 of f of x dx plus our integral from 0 to 3 of f of x dx plus our integral from 3 to 8 of f of x dx. This should equal our integral from -2 to 8 of f of x dx. And so we know that the integral from -2 to 0 is 3, and the integral from 0 to 3 we do not know. That's what we're trying to find. And then from 3 to 8, we're going to get -6. Don't worry too much about what that means to have a negative area for that right now. We'll talk about that a little bit more whenever I get back. Just know that it can happen. You can have negative areas there. And then our integral from -2 to 8 is 10, so we're going to plug that in there. So we could just add the 6 over here and subtract that 3. So our integral from 0 to 3 of f of x dx is going to equal 13, and that'll be our answer for that one. So you're really just kind of piecing these parts together. For number 3, it asks us the integral from -2 to 3. Well, we already have -2 to 0, and we just found 0 to 3. So that would be the integral from -2 to 0 of f of x plus the integral from 0 to 3 of f of x, which would be 3 plus 13. So we get 16 for that problem. You don't necessarily have to show as much work as I've shown here, but this is how you'll do these problems. Okay, so our next one, we have a function that is integrable from -5 to 5, and they give us the integral from -5 to 1 and the integral from 1 to 5. So the first thing they want us to do is find the integral from -5 to 5, which is going to be piecing these two pieces together. So we would just have to do, not write quite as much on this one, 8 plus our -2, and that would give us 6 as our answer here. Number 5 is a little bit different. It asks us to find the integral from 1 to 5 of g of x plus 5. So they're adding 5 to our function here. So we can break these apart. We can write this as the integral from 1 to 5 of g of x dx plus the integral from 1 to 5 of just that 5 dx. And remember that dx just tells us we're taking the integral with respect to x, so we just need it with each problem, but it really doesn't do a lot as far as what we're dealing with here. So I know the integral from 1 to 5 of g of x dx is -2, so I'm going to put that right here. And then the integral here, this is a constant number, so we're going to use that last property that we looked at. What we're dealing with is just a rectangle here. So this is going to be 5 times, we're going to subtract these, 5 times 5 minus 1. So -2 plus, that's going to be 5 times 4, 20 right there, and so 18 would be our answer. So whenever we have this right here, we can just split that up and use those properties of integrals for constants to help us out there. And then the last one that we have for this section is that we have a coefficient right here. And those coefficients, they can just sort of be brought out front. We already found the integral from -5 to 5 of g of x dx in number 4. So this is just going to be 3 times 6, which will give us 18. Okay. Let's look at a few more. Here is a multiple choice question like you might see. So this graph gives us the function f from -4 to 7, and it consists of 3 line segments and 2 semicircles, as shown in the figure above. And we are asked to find the value of the integral from -4 to 7 of f of x dx. So, well, I think I'm going to have to explain those negative values here in a second. It's pretty easy to do. So what we can do here is we can break this into sections. So over here, from -4 to -2, we are just finding the area under that curve. Obviously, that's a rectangle, so it's just going to be 2 right there. Then we could find our area underneath the curve from -2 up to +2. And this is a semicircle that is sitting on top of this little skinny rectangle right here. So this part right here would be 4. And then this part right here has a radius of 2. So it would be pi times 2 squared, which would give us 4 pi, but then we would have to divide it by 2 because it's only a semicircle, so we would get 2 pi for this area right here. Then we have this little tiny triangle right here, and its area would just be 1/2. Now, this is going to be a little bit different. We haven't really seen this happen yet, but when we have lines that are below the x-axis, we are still looking, whenever we integrate, for the area that is between our curve and the x-axis. But if our area is below the x-axis, it is going to have a negative value for the integral. So right here, we're looking at this semicircle right here that would be pi times 1 squared, which would give us just pi. And we would have to take half of it because it's just a semicircle. But we would count this value as a negative value because it's below the x-axis. Same thing would happen over here. This triangle right here would be 1/2 times 2 times 1, which would just give us 1. But because it's below the x-axis, it's going to have a negative value. So what we would do to find the area under the curve from -4 to 7, or the integral from -4 to 7 of f of x, is we would do 2 plus 4 plus 2 pi plus 1/2. But then we would have to do minus pi over 3 minus 1/2. I'm sorry, that's minus 1 for that last part, not a 1/2. So if we put this stuff together, I'm going to have 2, 4, and subtract 1, that gives me 5 plus 1/2 plus 2 pi minus pi over 3. So this would be 10 halves plus 1/2. And then we got, let's make this over 3 as well. So it'd be 6 pi over 3 minus pi over 3. And that would give us 11 over 2 plus 5 pi over 3. There, and they write it with the pi first, so I've messed this up. So that's not an answer choice. That was supposed to be pi over 2. I don't know why I made it a 3 right there, which means we need to do this differently. This is supposed to be pi over 2, which means this needs to be over 2, which will give me 4 pi over 2, which instead of giving me 5 pi over 3 there, will be 3 pi over 2. And so B would be our answer there. Okay. Our next problem is going to ask for the integral. Or it's going to ask us to find a value here. We've got the integral from -1 to 3 of 2g of x plus 4 dx is going to equal 22. And they tell us that the integral from 10 to -1 is 12. And then they're asking us for the integral from 3 to 10. So if we look at what we've got here, we know that this equals 22. So we could split this up a little bit. Our integral from -1 to 3 of 2g of x plus 4 can be split into the integral from -1 to 3 of 2g of x dx plus the integral from -1 to 3 of 4 dx, and this would have to equal 22. So this 2 right here, we could pull it out as a coefficient. And if we do that, that's going to look like this. We'll have a 2, and then the integral from -1 to 3 of g of x dx, plus we'll have right here, this is a constant, so we're just doing 4 times the length from -1 to 3. So you can think of it like this, 3 minus -1, and of course that double negative there becomes a positive. So this is just going to give you 4 here. And now you just really have an equation to solve, and what you're going to do is solve it for this integral from -1 to 3. This isn't going to give us our final answer, but it's going to give us a piece of information that we can use to find the final answer. So here this is going to be 2 integral from -1 to 3 of g of x dx plus 16 equals 22, and we're just going to subtract 16 from both sides. Whenever we do that, we got 2 times the integral from 1 to 3 of g of x dx, and that is going to equal 6 there. We're going to divide both sides by 2. And so my integral from -1 to 3 of g of x dx is going to be 3. So since this is 3, what we have here is they've told us the integral from 10 to -1. Well, these limits are backwards. We usually want that lowest limit to be first. So I'm going to switch these and make this -1 to 10. When I do that, I also have to change the sign of what it is equal to. So my integral from -1 to 10 of g of x dx is going to equal -12. And so if this integral from -1 to 10 equals -12, then if I take the integral from -1 to 3 and add it to the integral from 3 to 10, I should get -12. So we can make ourselves the second equation where we're saying the integral from -1 to 3 of g of x dx plus the integral from 3 to 10 of g of x dx should equal that -12 that we have for our integral from -1 to 10. And so we know this value right here is 3. So we got 3 plus the integral from 3 to 10 of g of x dx. That equals -12. And so we just need to subtract 3 from both sides, and our integral from 3 to 10 of g of x dx should equal -15. And so B would be our answer for that one also. We are actually going to skip this example for right now because it would have been helpful if I had done one more activity with you guys before we left. I think you should still be able to do the assignment without doing this, but we'll look at a problem like this whenever I return. So your assignment will be from the book. These are the problems that you're going to be looking at. I will be checking my email if you have any questions that you want to send me about that, and I will check this assignment. Well, I won't check this assignment. Ms. Hendrick will check this assignment tomorrow.